this is very interesting experiment. I call it magnetic pendulum because this pendulum having a rigid frame, nylon thread and very strong magnet. This magnet is super strong magnet called as neodymium magnet, and these neodymium magnets are famous for their large strength. So when I make this pendulum to oscillate in free oscillations, we can observe that its period depends upon the length of the pendulum, that is from center of mass of this to the fixed point here, and this period will change if I change the length. It is root L proportion. Now if I make this pendulum to oscillate, it has certain amplitude, and this amplitude remains constant for a long time. It will go on decreasing because of air resistance. But if I keep the slab of aluminum below this pendulum, now you can see that this pendulum and this slab has no attraction at all because this is paramagnetic substance. So this paramagnetic has very weak interaction with the magnet. This paramagnetic slab has very weak interaction with the magnet. And if I give the oscillations to this with the slab below without touching it, of course, not touching at all, you can see the funny phenomenon occurring here. When I leave this, you can see what happens. Stop. So within 1 or 2 oscillations, it will come to rest. Now the question arises, why the pendulum stops without making touch, without making contact. Even you can see this action more vigorously. This is somewhat 1.5 oscillation complete, okay. But if I make this length little bit more and now it is just verge of touching, you can see, yes, it will suddenly stop. It appears like magnetic brake. Now what is magnetic brake here? When a magnet moves over the slab, it will induce the currents in the slab, and those currents are called as eddy currents. And these eddy currents are so strong that they generate their own magnetic field, and that magnetic field always opposes the motion of the magnet, called as Faraday's law and Lenz's law. This Faraday's law and Lenz's law are extremely important in physics because the whole electromagnetic theory is based upon this Faraday's law and Lenz's law. Pioneer experiment done by Michael Faraday and Lenz, and they made very interesting observations. One of this is eddy current, and this pendulum, when I leave from some distance, it goes 1.5 oscillation back and stop. This is because of very strong opposition to motion by the slab, and if I now remove this slab and make the oscillations, it is a free oscillation. There is no break. But if I keep the slab, I get a break. Now I can show you something more interesting. Suppose I keep a copper plate which is diamagnetic. This was paramagnetic, and now I am taking diamagnetic. And if I keep the copper plate with a typical shape, the shape is very important. You can see the plate is able to rotate because it is slightly convex or concave here. And you can see the funny thing happening now. Here you can observe, okay, now I can make the distance still less so that the effect will be more dominating, and you can see the effect very clearly now. Okay, this is interesting. Now question is, why this goes around along with the magnet? The answer is very simple. The magnet is trying to move over the plate opposes the motion, and in opposing the motion it will get force acting on it which will be trying to stop the magnet, and this force will be making the rotations. It is like torque applied because of this force, and this is very interesting observation. Right? See the motion, okay. If you make it more convex and more curvature, and you can have still smooth oscillations, yes, okay. And if you give long amplitude, you can get more, and if you give the angular, you can see the changes, yes, it is changing, okay, fine. Same thing we can observe with some other surfaces also. Now the distance is slightly more, we can make the distance slightly less, and we can make this almost touching. If it is slightly less weight, it is better. If I keep this, now question is why it is going forward and backward. That is what we have to think. We have to think and find the answer. So that is what observation. You can see the plate is going forward, backward, and now it is changing direction. And so many things are there. Right? We can have even a slab, and that also will have an effect if the slab is pushed. It is getting pushed ahead, and if the distance is still less, it is still better. It has made the slab to move. Yeah, fine. Thank you.